Hi Math 3 students! Today we are going to be going over how to graph something called logarithms or logs. So the first thing we're going to do here is graph something we are familiar with, and that is going to be an exponential function, 2 to the power of x. All right, so what this is where we're going to take, we're going to plug in values. How about we're going to plug in, let's do 0, 1, 2, 3, and 4, okay? Now, just so you know what we're doing here, when we go and plug in 0, we're just doing like 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, and so on. You can see here that I have already plugged these in to save time for you. I'm trying not to make this video too long here. So when we plug those values in, we get 1, 2, 4, 8, and 16. All right. And one thing I wanted to make sure you do for this video is make sure that you have three different colors. So make sure you have like 3 different colored pens, colored pencils, like really thin, if you have like the flare pens, thin markers. Don't use like the big fat markers. That's not going to look good. But 3 different colors is going to be really helpful here. All right, so this is, these are the points, all right, and this is what the graph looks like. Now, let's go ahead and actually graph these points here. So I want to graph 0, 1, 1, 2, 3, 8, oh, I skipped 2, 4, that was silly, 2, 4, I'm like, why did I skip that? 3, 8, and then 4, 16 is off the graph, so we're not going to graph that here. And if you look at this function, do you see how it continues on and on and on here? But the y value, right, the x values keep going smaller and smaller, but the y values kind of level off, but they do continue to keep decreasing, right? Do you see how it just goes down, goes down, goes down, goes down? So that's what we call an asymptote, all right? So what happens is this function gets closer and closer to this asymptote here at 0, but never reaches it. So it's going to look like that. Now, the domain of this function, okay, we can plug in whatever x values we want to this function, and we're going to get an output. There's nothing that you're going to plug into x here that's going to give you an error. So our domain is going to be negative infinity to positive infinity. However, the range, if you look at the y values, you always want to go, when you're looking at the range, go like down to up, right? We don't hit any values until we get close to 0. But remember how I said the output is never actually 0? So the way that we would show the range is it goes open bracket at 0 to positive infinity. We don't do a closed bracket at 0 because it never actually hits 0. I don't know why I did that in pink, but whatever. All right. So now let's go ahead and do the graph of log base 2 of x. Okay. Now, I want to point out, I obviously am familiar with graphing logarithms, so I know what values to plug in for x. Until you kind of get familiar with these, I wouldn't expect you to know which values of x to plug in until you're familiar. Okay, so if you're looking like, well, why did she plug that in for x? I just did that because I know it's going to work nicely. All right, so if we look here, all right, we've got our values. Now, if I do 0, I get something called undefined. Okay, and we'll talk about that later. But basically, when I plug in 0, it tells me, nope, can't do it. When I plug in 2, I get a 1. When I plug in, oh, I guess actually we should plug in a 1 as well. Let's do that. Will it let me? There we go. Okay, sorry, I meant to plug in a 1 here. When we plug in a 1, we get a 0 out. When we get a 2, we get a 1. 4, we get a 2. 8, we get a 3. And we're going to add one more down here. 16, we get a 4. Okay? So, if we look at these guys here, what ends up happening, oh, actually, and you know what we could do? I'm going to go here then and add in one more value. Let's see what would give us. We get 1, 0. Oh, because it never reaches 0. Duh, never mind. All right, having a goofy moment. All right, so now let's go ahead and look at this black graph, okay? I love how I did this in red style. Let's turn this into black just for continuity's sake here. And we will turn this into red because then they'll match the graphs we got. Isn't that lovely? All right, so we have our graph of our logarithm here. Again, I just knew what values to plug in to give me nice y values. Now, if we go ahead and graph this, we've got, so 0 doesn't work. So keep that in mind. We get undefined value at 0. Then we're going to go ahead and go to, we got a point at 1, 0. We've got a point at 2, 1. And then we've got a point at 4, 2. And we've got a point at 8, 3. All right. And if you notice, the graph of the logarithm actually has an asymptote here that goes in, that kind of hugs the y-axis, right? So our logarithm looks like this, okay? Then if we look at our domain, all right, so those are the x values that we can plug in, all right? Now notice I had no issues plugging in x values until I got to 0, right? Let's see, what if I plug in something that is in between 0 and 1, 0.25. So I get a happy value for that, right? If I do 0.25, I get -2 as my answer. So I don't run into an issue until I get to 0. Even if I go really close to 0, I still get a value, all right? But once I hit 0, I get an undefined value. So what that means is I cannot plug 0 in, okay? Now what happens if I plug in a -1? I also get an undefined value. And that makes sense if you're looking at this graph. You don't see any points past an x value of 0. And that's because the domain of this function is 0 to infinity. All right? And then if we look at our range, right? Again, when you look at the range, you want to look at the y values. You can see that this arrow goes down. So it goes down to -infinity. And even though this graph grows really slow, all right, this continues to increase, right? It goes from 647. Let's see, we should be able to get to 700. Oh, we got 900. Okay, so do you see how it does continue to grow? It doesn't level off. It doesn't have an asymptote there is kind of what I'm trying to get at. So it continues to grow, which means that our y values are going to go from -infinity to +infinity. Okay? Now, one more thing that's kind of cool is I'm going to throw in the line y equals x. Okay? Now, last unit, we talked about, actually we had last unit, there's a specific word that we learned about, and I want you to think back to what that word is, right? If you notice, these two graphs reflect over the line y equals x, all right? Additionally, all right, look at the x and the y values, right? Here I have 0, 1, 2, 3, 4. Here I have 0, 1, 2, 3, 4 for my, so notice how my x values went to my y values. And then here I've got 1, 2, 4, 8, 16, 1, 2, 4, 8, 16. Now my y values became my x values, okay? So based on what we did last unit, all right, what do you think you could say about the functions 2 to the power of x and log base 2 of x? So these two functions are inverses. All right. So kind of cool, right? Now, the rest of the video is going to be specifically on graphing and transforming logarithms. All right. So we're not going to do any more with exponents. We're just going to deal with logs specifically. Now let's go ahead, and we already know our good values for log base 2 of x. So let's go ahead and fill those in. We're going to do, so pick up one of your colors. We're going to graph that in log base 2 of x. We're going to do 2, 1. I keep forgetting to do 1. I'm sorry. 2, 2, 2. 1, 0, 2, 1, 4, 2, 8, 3, and 16, 4. All right. And of course, we need to go graph this in one of our colors here. 1, 0, 2, 1, and 4, 2, and 8, 3. Again, we have our asymptote here. All right. All right, so we got that guy done. Now let's go ahead. We are going to graph log base. Let's see, I'm going to take all these guys off. All right, so that was our graph of log base 2 of x. All right, now we're going to go ahead and graph log base 3 of x. All right, and let's make a cute, nifty little chart here. And again, I know what numbers to plug in to make this look nice, and eventually you will too. All right, so apparently I'm going to use purple here. Let's see, how do I change my color on this? What the heck? I think I can do, are you kidding me? That's so lame. Why can't I figure out how to change my color? Sorry, they updated this app, and I used to like know all the little tricks and stuff. See, why don't I? Oh, I guess I have to delete a color to get a plus. Look at that. All right, see, we're figuring it out. All right, so we're gonna use purple. All right. So we're gonna start by let's see. We'll plug in. What the heck? All right, we're gonna plug in 1. That's my alarm to wake up. It's 5:10 in the morning. LOL. All right, plug in 1, 3, 9, and 27. All right, so we get 1, 3, 9, 27. And we get 0, 1, 2, 3. Now, how did I know to plug these values in, right? Like if I plug in a 2, I get something gross. All right. I know that this is going to work because remember how these are like the inverse of exponential functions, right? So I know that if I do like 3 to the power of 0, I get 1, right? If I do 3 to the power of, or if I do 3 to the power of 1, I get 3. If I do 3 to the power of 2, I get 9. If I do 3 to the power of 3, I get 27. So that's how I knew to plug in those x values to get those nice y values out. All right. So let's go ahead and graph. We get 1, 0. So we're going to, oh, I did not mean to erase that. We get that guy. Then we go to 3, 1, and then 9, 2. Now, of course, 27, 3 is off the chart, but we can always go ahead and graph our little asymptote here. And this is our next function. All right. Now we'll go ahead. We've got another one to do. And we've got log base 4 of x. And when I do this, all right, I'm going to plug in my 1 that I always plug in. Now, again, think about like, okay, if I want to get a 1 out, it's going to be 4 to the power of 1, which is 4. 4 to the power of 2, which is 16. And then, I don't even know what 4 would be. Was that 64, right? 16 times 4? Yes. So this would be 64. All right. So we get our 1, 0, 4, 1, 16, 2, and then 64, 3. And I forgot to change my color. Let's see, what color is this? This one is blue. All right. So now let's go ahead and change our color again here in graph. Again, we get 1, 0, all right? And then we're going to do 4, 1. And then, unfortunately, 16, 2 is off the graph. That's going to be like, I don't know, around here, okay? So we can go ahead and whoosh, like that. All right. So, I want you to stop and think. What are some of the similarities of these? Sorry. All right. So, what are some of the similarities and differences, right? So, some things that I want you guys to think about are this point, all right, and this point. What are you noticing here? And maybe see the connection between the base of the logarithm. All right. So all of these guys, all of these graphs go through the point 1, 0. All right. And then they all go through, the point base, comma, 1. Okay, so if you look, right, it's like our base is 2, 2, 1. Our base is 3, 3, 1. Our base is 4, 4, 1. Okay, so these are what I'm going to refer to as our anchor points. Okay, so our anchor points are going to be 1, 0, and then your base, 1. Now, additionally, they all have an asymptote at, oh my goodness, Alexa, stop. Oh my God, Alexa, stop. I don't know why she does that. She does that every morning. Now, one thing as a teacher I always struggle with, I can never remember how to spell asymptote. I'll have an asymptote at, it would be x equals 0. All right, that's this asymptote here at x equals 0. All right, so the features of a parent logarithmic function include 1, 0, b, 1, and x equals 0. All right. So again, these are going to be anchor points that we refer to. I should say asymptote. Yeah. All right. So now we're going to talk about actually transforming these graphs. Now, fortunately, I actually have them all ready to go, so these should be nice and quick. All right. So let's see. In one color, let's go ahead and fill in our chart. We've already filled in the chart here for log base 2 of x, right? So we know we've got our 1, 0 point. We've got our 2, 1 point, our 4, 2 point, and our 8, 3 point, and our 16, 4 point. All right. And of course, we need to go and graph that. We have our asymptote that we talked about right here. And we've got 1, 0, 2, 1, and 4, 2. All right. Oh, and then we can do our 8, 3 as well. All right. Now, I'm going to go ahead and graph this other function they're asking us to graph. All right, so our nice points for this function are going to be -4, 0, -1, 2, 3, 3, and then 11, 4. All right, so if we go ahead and take a look here, right, you can see that these points, right, our 2, our 3, and our 4 are still, and our 1 here, right? They're still here, right? However, they kind of got shifted a little bit, all right? So what ended up happening here, let's see, what if I put in, can I just put in a 1? Will it let me? No. All right. So what ended up happening here is the graph got shifted, okay? So let's go ahead and look at these. I'm going to go ahead and actually graph these two, okay? Well, we've got our original graph in red and our second graph in purple here. And we can see that this graph shifted to the left, right? And how much did it shift to the left? Well, if we look at, so when something's shifting side to side, that means you're changing the x values, all right? Our y values didn't change at all here, but our x values did, right? So the guy that used to be with 2, all right, is now -1. Well, what used to be with 2? 4, okay? Well, how did we go from 4 to -1? We subtracted 5. Okay, so essentially what we did is we subtracted 5 from the x values, all right? So let's go ahead, we'll graph our purple graph here, and we've got -4, 0. Oh, and I guess I probably should have done, let's see, a -3 would have been helpful then, right? So, yeah. Sorry. I know I should have put this in here originally. I'm trying my best. We could put a -3, 1 in here so it looks nicer. -3, 1, and then -1, 2, and 3, 3, and 11, 4 we actually can get on here too. All right. Now, the asymptote, okay? If we look, where is our asymptote at now? Well, it is at -5. You see how it's getting closer and closer to -5? So at -5, we are going to draw our asymptote. Notice how our asymptote is literally the opposite of this value. That's very important. So we go ahead, graph this bad boy here, and that's what we get. All right, now another color. We're going to go ahead and graph log base 2 of x -3, okay? So we've got, let's see, what color is this guy in? He is blue. All right, so let's get a blue color. And we've got, excuse me, 4, 0, 5, 1, 7, 2, 11, 3, and 19, 4. So again, if we compare these values to where we started, right? Our original 0, 1, 2, 3, 4. We went from 1 to 4, 2 to 5, 4 to 7, 11, or 8 to 11. What's happening here? We are adding 3 to x values. All right. So if we go ahead and graph this, let's go, we get 4, 0, and 5, 1, and 7, 2, and then 11, 3. And then we can go ahead. Oh, I didn't draw on my asymptote. Let's look. Where's our new asymptote here? It is getting closer and closer to 3, right? And remember what I said, the asymptote is the opposite of this guy. So we have our asymptote here at 3. All right, so what happens when you add or subtract a number inside of the log? Well, it's going to shift left and right. Okay, if it is a positive number, it's going to shift to the left, right? If we look at these graphs, right? When we added, that's that purple one, we shifted to the left. All right, and when we subtract on the inside there, we shift to the right. All right. And basically, the asymptote is just going to be x equals the opposite of whatever that number is on the inside. Okay. So it's basically just going to be x equals, I don't know, I guess you could do like, we could just say x equals opposite of number on the inside, right? All right, cool stuff. Now, let's go ahead and take a look at our last transformation we're going to go over here. All right, so the first thing we've got is our parent function, which we've already graphed a gajillion times here, right? For our parent function, we know we are going to do 1, 0, 2, 1, 4, 2, 8, 3, and 16, 4. All right. Now let's go ahead and instead of adding and subtracting on the inside of the function, we are going to add and subtract on the outside of the function. Now, one thing I want to point out is this 3 can either be out in front, added out in front, or you could write it like this. Make sure you write this down because I want to make sure you guys understand that these guys are equivalent. All right, so let's graph this guy in a different color. And we end up with 1, 3, 2, 4, 4, 5, and then 8, 6, and 16, 7. All right. And, oh, I forgot to graph my parent. Nuts. Let's do that. And then we get 1, 0, 2, 1, 4, 2, and 8, 3. That was our original. All right, and now we've got our new one here, which we said is 1, 3. All right, and 2, 4, and 4, whoops. Sorry, 2, 4. 4, 5, and 8, 6. And the 16 obviously is off the chart. Okay, so when we look at these two graphs, right, we started with the graph in red, right? If you look at the asymptote, that stayed in the same location, all right? Which makes sense because remember how I said the asymptote is going to be the opposite of the number you're adding or subtracting on the inside? Well, we're not adding or subtracting anything, so it's going to stay at 0. All right. So just based on this, right, what happens when we add or subtract on the outside? Which way did this shift? If we look at the red, going to the blue. So when we add or subtract on the outside of the log, it goes up and down. All right. Here, let's graph one more to see what happens when we subtract specifically. All right. And as you can see here, it went down, right? So this function went down. We're going to go ahead and write out our coordinates here. We've got 1, 2, 4, 8, and 16. And our outputs are -4, -3, -2, -1, and 0. Now, what's happening to our y values here, right? Notice how our x values stayed the same, but our y values, what did we do? We subtracted 4, okay? Okay, so we're going to subtract 4 from the y values. Now, what happened to the asymptote here? Nothing. Right? Shifting up and down isn't going to change the asymptote. Shifting left and right is going to change the asymptote. All right? So, kind of a big summary I want you guys to think of. Maybe kind of just like in this little corner over here. All right? If we have a log base something, okay, if we add Okay, let's just say, I guess I'll make up an actual problem here. Let's say log base 3, and we're going to add 8. Okay, if we think back to what we learned on the inside, if we add 8, okay, that means that we are going to shift left 8. Okay, essentially what we're doing is we are, and if we go back here, what happened to our x values, right? Here we went from 1 to, we went from 1 to 4. We added 3. Here we went from 1 to -4. We subtracted 5. All right. So if we look at the plus 8, all right, what are we going to do to our x values? We are going to subtract 8 from x values. All right. If we had something like this, all right, that -3 means we are going to subtract 3 from y values. So now let's go ahead, just kind of with this as like a little summary, let's go and try and answer this question, right? So we added 3, I meant to highlight. We added 3 on the outside, and we subtracted 6 on the inside, okay? So what I would predict here is we are going to go 3 up, all right? And the -6 means that I'm going to go right 6. All right? Now, if you recall, the asymptote is the opposite of this guy. Our asymptote is going to be x equals 6. Now, if you recall, all of these points have a 1, 0 point. These are going to be our anchor points, and we're always going to use them. So we're going to take our 1, 0 point, and we said we need 2. The 3, we are going to add 3 to our y value, okay? And then the -6, remember we have to do the opposite to our x value. So we're actually going to add 6 to our x value. So my new 1, 0 point is going to be 7, 3. Now let's see if I'm right. Hopefully I am. That would be awkward, right? So we've got, let's see, x -6. And then we got to add a +3 on the outside here. And we said that the 0.73 should be on here, right? And look, it is. All right. So that was our new 1, 0 point. Our new base, 1. Well, what was our base here to begin with? We had 2, right? Because it's a base 2. So it's going to, we have our 2, 1 point. And again, to it, we have to add 6 and add 3. So we're going to get 8, 4. All right, and let's see. Do we have the 0.8, 4? We do. All right. And, of course, we could go ahead and show that we do, in fact, have an asymptote here at x equals 6. So whenever you get a function like this, the 3 things you're going to have to look for is you're going to have to transform your 1, 0 point, transform your base 1 point, figure out what your asymptote is. Then you also should be able to describe the transformation, right? Did it go up, down, left, right? So yeah, all right.